Okay, so why don't you try and do the problem, pause the video, and then after you've tried to do the problem, we can go through it. Okay, so this is a sequence problem, and it is, it's worded very complex, but it's actually not that complex. So the biggest issue with this problem is notation. So let me just go through it really quickly. So this is asking for a sequence, and it's giving you a sequence of a1 plus a sub 2 plus dot 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 plus a sub n. And that's what those little numbers are to the right of the letters. It's just sub. So a sub 1, a sub 2, all the way to a sub n. And this dot 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 plus a sub n just means it's ending at some indeterminate point. And then it says begins with the numbers 3, 11, and 18. And what that seems to be indicating is basically a sub 1 is going to be 3, a sub 2 is going to be 11, and a sub 3, if it was there, would be 18. Right, so that's kind of the idea. So now, and it says it has the nth term. So this the nth term here actually corresponds to the letter n here. Right, so you can see like this is a sub 1, a sub 2, a sub 3. This a sub n would be the nth term of this sequence, is defined as a sub 1, which is just the first of this sequence, plus 2 times n plus n squared. And again, these n's are all the same. So the nth term, a sub n, and this n right here are all the same. Okay, so if we look at this formula right here and we write it down here, a sub 1 plus 2n plus n squared. And they want to know, and this n is corresponding to the nth term, okay, right here. And they said, what is the 20th term of the sequence? What they're saying here is let n equal 20. If the nth term, if the 20th term. So we have to let n equal 20. So that means we take this formula and we put 20 where n is. So it becomes 2 times 20 plus 20 squared plus a sub 1. Okay? So now the only big question we have left is what is a sub 1? Well, we know what a sub 1 is because they gave it to us right here. They said begins with the numbers 3, 11, 18. So a sub 1, 3. Okay? So that means that we get 3 plus 2 times 20 plus 20 squared. Alright, so what's 20 squared? You can just do that really quickly. You get 0. 2 times 0, 0 times 2 is 4. It's 400. So you get 400 plus 2 times 20 is 40 plus 3. So you get 400 plus 40 plus 3, which is 443. So that should be your answer. And that is indeed this right here. Now, let's see if we can test this. Because one thing we didn't use is we didn't use 11 or 18, right? So you could consider these two a distraction. But another way to think about it is it's a way to test your formula, all right? So let's say you have a sub 1 plus 2n plus n squared for the nth term. And let's look at 11. 11 should be our second term, right? So this is our first term, a sub 1. This should be a sub 2 is 11. All right, so if that is the case, our second term should be a sub 1 plus 2 times n plus n squared, where n is equal to 2. So a sub 1 we've already learned is 3 plus 2 times, and then n is our second term, so it's 2, plus 2 squared. Turns into 4 plus 4 plus 3, which is 8 plus 3, which is equal to 11. So you can see how you can confirm this sequence by using these numbers. So again, we could try it for this one as well, 18, right? We could do the same thing. We could have it be a sub 1 plus 2n plus n squared using this formula. For the third term, we're looking at n equal to 3. So this turns into, we know that a sub 1 is equal to 3. So we've got 3 plus 2 times 3 plus 3 squared. 3 squared is 9, plus 2 times 3 is 6, plus 3 is 3, plus 6 is 9, plus 9, which is equal to 18. So again, you can see we have now this term. So we could have used 11 and 18 to confirm our use of 3 for a sub 1, or confirm our use of this formula. But we didn't have to, right? So we had already gotten to the answer by just looking at 443. Yeah, so that's how you do this problem, and it really seems like the biggest issue with this problem is just the notation, right? It just seems like it's overly complicated, and that kind of seems to be what they're kind of going for here.